record this. Okay, so so these recordings, because my mind works very slowly these days, I figured out over the weekend I should just be putting these recordings in our playlist. Remember the YouTube playlist that we used to watch? Yes, I'm just going to throw them in there rather than individually emailing out links. That seems like a better idea. So after class, after this video is up on YouTube, morning.
Morning, guys.
So after I'm done making this and putting it on YouTube, I'm not going to send you a link in an email. It'll just be in the YouTube playlist. Okay, so let's just look at the schedule real quick. We only have 2 weeks of class left. So the semester has seemed both very quick and also excruciatingly slowly to me. Anyway, that's how time works nowadays. Extremely slow, but also extremely quick. So what we're going to do for this week is talk about data from the Social Security Administration, baby name data. So I'm just going to show you how you can visualize that, some ways you can iterate your way through the data with for loops and things like that. So we're just going to use this data set as another sort of playground, like we did this data last week. This just is kind of a playground for doing certain things, mainly visualizations and some looping your way through various rows if you want to do that kind of thing. And then next week, we'll just continue with this and mostly just review for the final. So we'll have like maybe 1 day of this stuff next week, and then at least Wednesday and Friday, we'll just be reviewing for the final, just making it very clear what the final is and what kind of problems you lose. Yeah.
Do we have like an exam for the data analysis part of the course?
Not separately, no. They'll just be rolled into the final.
Okay. But we have like a full course final.
Right. Yeah.
Okay.
So one thing you may want to think about is, so for the last 2 exams, in my opinion, the most important thing was just organizing the code you have to make it grabbable. So you may just want to think about how you do that for this. Yeah, there's no separate data analysis exam. So anyway, that's what the schedule is. So 3 or 4 more days playing with baby name data from the Social Security Administration, and then preparing for a final. And hopefully your final is like the previous 2 exams. Those previous 2 exams class-wide went really well with really high medians. And the final, at least when I write it, will be no different in format. So hopefully the final will go just like the other 2 exams, but we can talk about that later. Okay, so what I want to now do is, you'll notice for today, there's no spreadsheet here. The reason is because the data we're going to crunch is too large for me to put on Moodle. Moodle won't let me put it there. So let's go ahead and just go ahead and download the sample code. And Carolyn, unfortunately, because of the way your computer works, there's code just for you. So it's not much different, but the way it eats in the spreadsheets is different. Anyway, so go ahead and grab that code, and then I'll show you where to grab the data from that we'll use. So the code should look something like this. It's broken down by panel, so panel 1 or pane, whatever, panel 2, and so on. So we'll go to JupyterLab and use this in a second. So just have that ready. So the data we're going to get is from the Social Security Administration. So let me show you where to go. I don't know how to make this bar any bigger, so I apologize for how small this is, but you do SSA. So go ahead, and if you don't have a web browser open, go ahead and open it up. So SSA for Social Security Administration .gov/data is what you want.
We're just going right to their website.
Yeah, and for those of you in the Zoom, here's that link, and this is what you want to type. SSA.gov/data. Yeah, okay, so now I'm actually there. Maybe this is the better link, I don't know. I guess the old link was missing www. Anyway, SSA.gov/data. You should see a page that looks like this. If you don't see that, let me know. Okay, so now we scroll down to where it says data assets. And notice it says there are 2,066 entries. There are a ton of spreadsheets you can download from the Social Security Administration. We want only one of them though. So type baby state like this. So search all columns, baby state. When you do that, there should be only one hit: baby names from Social Security card applications, state, and DC. This is the data set we want. Everybody see that? So downloads, when it says zip, go ahead and hit that zip. and it should download for you. So it's going to take a little while because it's a lot of data. For me, it says like it's going to take 1 minute to download. So let's just let that download.
Do you want to put it on our desktop?
Yeah, so once it's downloaded, you put it on your desktop. So while it's downloading, let me just show you. Oh, oops. Yeah, as always, if I forget to reshare, you got to yell at me. So let me just show you. Oh, so none of that was sharing? All right, so sorry. So once you're at ssa.gov/data, you scroll down, there's a search bar right here. Initially, it was empty. So it just lists all 2,000 spreadsheets they have. So if you search baby state, that's the one you want. So baby state, there's a zip. You download that. See, for me, it's still downloading. It's a lot of data. Also, it's downloading over Joule's secure network. So when I download this at my house with Google Fiber, much faster. But anyway, so for you, while that's downloading, once it's done downloading, you can move it to your desktop. I already have it on my desktop. It should create a file called names by state. So it downloads as a zip. So if you open the zip, you know, on a PC, it'll look different, but if you have it unzipped, it unzips it, creates something called names by state. So again, I already have this on my desktop. So, but if I were you now, I'd move it onto my desktop. Okay, so for some of you, it might still be downloading. Let me just show you what this data looks like. So every single state in the US and also DC has a text file in here. So California.txt. If you open that, let me show you what it looks like. Make it bigger. Okay, so every single state has a file like this, where a row tells you the state you're in, the sex of the baby, the year, a name, and then the number of babies with that name. So in 1910, there were 295 female babies born that were named Mary. And then in 1910, 239 babies born named Helen. That's the kind of data we're downloading. So let me pause and ask, anybody have any issues? And I'll check the chat and then hopefully remember to reshare. Any issues grabbing that spreadsheet, or not spreadsheet, sorry, the folder, names by state? Anybody in here have an issue? Yeah, Monday, April 26th, yeah. So again, this data is not on Moodle because it's too big. Moodle wouldn't let me put it on there. So anybody in here, anybody on Zoom have trouble grabbing that? You guys all have that? So you're able to go in, open the files like this. It looks like this. So Sabrina, you okay? Ian, you got it? Again, if you're on Zoom and you're having trouble, you got to shout out. If you chat, I can't always tell because sometimes it won't pop up a little notification. Okay, so again, if you're having trouble, you should shout out, but I'll give you another minute to download it if you're having trouble. So let's just look at this real quick. So I already told you what this is. Notice this is like, if you look at these names, it lists them from most popular to least popular. So Mary was the most common name in 1910 in California of female names. So Mary, Helen, Dorothy, Margaret, Frances, right? So these are old-timey names, right? Mildred, do you guys know any Mildreds?
Yeah.
Oh, you do? All right, well, I'll take it back. Anyway, this is in the top, what is this, top 15 popular names in California. Hazel, that's classic, right? That's coming back. I don't know if Edna's coming back. You guys know any Ednas? Huh? Your grandma?
Yeah.
Yeah. Anyway, so there's like a lot of data in here. You know, if I keep scrolling, so he goes all the way up to the 1980s, and I think he goes through 2019 maybe. They might not have the 2020 data ready yet. Let's just see. Yeah, so you gotta scroll a ways. Okay, I scrolled too far. Sorry, I know this is like giving you a seizure. Whoa, why is it? I'm in the 1950s. Okay. So they have 2019 data. They do not have 2020 data. Yeah, so the most popular female name in 2019, let's see. Yeah, there's a lot more data the farther you go, just because there's more people and more diversity of names. Man, okay. It didn't take me long to get out of 1910, but 2019, I'm not even close to the top. Oh, okay. 2000. So obviously it's better to have Jupyter Lab do this for us, which I'll show you. Am I close? So close.
Right there.
Sophia. Oh no, Mia. No,
Olivia.
Olivia. Right. Almost 2,600 of those in California. Anyway, and so then if you keep scrolling, there's also male data, you know. So this contains, with some caveats that I'll outline in a second, this contains all baby name data dating back to 1910. The only exception is that you'll notice, see how it stops at 5? So there were 5 Zianas or Zianas, I'm not sure how you pronounce it, in 2008. And notice there's no 4, 3, 2, or 1. Everybody see that? There were probably some names that only like 3 baby girls had, but they're not going to show them here. So basically, the SSA worries about privacy concerns. So it's not all baby names, but most of them. If you happen to have a name that's so unique that only 4 or fewer babies share it with you, or I guess 3 or fewer share it with you, you're not going to make it into this file. Anyway, a lot of data, you know, and then again, as we were scrolling, you'll get to male data. So every single one of these text files is like that. So 129 Calvins in 1953 in California, that's in there. Okay, so anyway, that's the kind of data we're dealing with. And it also comes with a little PDF that you can read if you want to, that documents it a little bit, but it's pretty straightforward. So any data you get from a high quality source, like say a federal government source is supposed to be high quality, it'll come with documentation like this. But again, this data is so like straightforward. It's just, you know, it's just state, sex, year, name, count is all it is. Okay, so now I think I filibustered long enough that everybody has it. So now let's go to Jupyter Lab. And again, I have a bunch of stuff here that we don't care about. I always start fresh though. Okay, so now if you have that sample code downloaded and you have your names by state on the desktop. Okay, so let's just grab this first pane. As always, I'm just copying and pasting because it's way faster than typing. So this just brings in a bunch of libraries that we need. So pandas is familiar to us. Seaborn is also familiar to us. It helps with regression lines. That's how we used it before. Matplotlib is basically the new one that we'll use to get plots of names. And these libraries are fairly big, so it actually took it a minute to load in. Okay, so now, actually, let me show you, Carolyn, just real quick, what you're gonna do. So now this is what you'll do, Carolyn, for pane 2. That's the only difference. But you actually have to do this. So sorry, this is just for Carolyn because her computer, well, yeah. It's really Catalina's fault. So Carolyn, what you have to do is you have to select all of these and then literally drag them in to Jupyter Lab. Oh yeah, I already did that. So it's asking me if I want to overwrite. Sorry, my computer's going so slow. Please stop. Make me cancel 50 times. Anyway, so I already did this to make sure it would work for you. But that's what you want to do. Just literally grab all of them, drag them over, and it'll drop them in. Like, see how I have California.txt there? That's what it should look like for you. Okay, so now, for everybody else, here's the next thing we're going to do. So there's a lot of code here, but a lot of it's documentation, and a lot of it you don't have to really worry about. So what this code is going to do is, notice it's going to go to the desktop and go to the folder names by state. It's just going to systematically eat in all the data that's in all those text files. So I'm going to go ahead and run this and show you what it does. So you see the little star right here? Everybody see that? That means it's thinking. Okay. There's a lot of data to process. So it's thinking, thinking, thinking. We can't move on to the next pane yet because it's thinking so hard. There's a lot of data, so it's going to take it a while to think about it. But what it's doing is it's using this OS library, see import OS, that exists just to go into this file, or sorry, go into this folder and grab all the separate files and then sort of stitch them all together. So here I'm saying like, hey, go in, find the text files, not the PDF. I don't care about the PDF. Go in and find the text files and then start eating them all in one by one. So here's a for loop right here. What this for loop is doing is it's going to the first file, then the second file, then the third file, and so on. It's grabbing all the data from each file and then concatenating that. See this concat down here? So it's doing Alaska and then concatenating with Arkansas, then concatenating California and Texas and so on. Just goes through file by file by file, eats each file in, and then throws it into the end of a data frame that it's making. So it's actually still thinking about this on my machine. My machine's running very slowly today. I probably should have restarted it before class, but it's just gonna take it a little while to eat all that data in. So before we move on, let me just ask, you guys okay with this? Is your lab thinking about it?
Wait, how much do you need to take? Like, is it like we just copy everything that's under hashtag?
Yeah, that's all you want. So you don't, I mean, there's plenty more code here, right? But you don't want to grab any more of that. So just pane soup.
I just copied it.
Hey. You already have it open.
Gotcha.
Your mind union error as well. Yeah, oh yeah. It's just sitting there on my desktop file. Like I checked a couple times to make sure it was there.
So it still has this little zipper on it, so it actually hasn't unprocessed it. So you gotta. Unzip option here.
Extract. How to create a file. Extract it.
Yeah, let's do that.
I would say these zip files on Microsoft.
Maybe just create a new file folder.
Oh, new.
New folder. So let's do this. I don't understand why it doesn't. But it just unzip it.
Oh, boy.
It's actually not gonna get it when I copy it, just goes on the machine. But right here, right here.
No, just names.
Also, there's
Oh.
another one, another path that you have.
Oh, what do you have to do?
So,
Right here.
names right here.
Oh, oops. Yeah, sorry.
I only know this because I don't put things on my desktop.
Yeah, I'm gonna start with Mark. You said Google open.
Yeah, right there.
That's fine.
Oh, boy.
Oh. That's fine. Oh.
Oh, it worked?
Yeah, so that's how you do it.
Oh, boy.
I don't know why,
So which one should I just go off of which one?
so now you can just, it doesn't matter. That was the only difference.
Right.
Yeah, doesn't matter. Hey, sorry, we had some issues with the machines in here. So if you're on Zoom, I still don't see any chats. If you're having issues with either, if you're having issues with this here, so a couple of students in class didn't recognize this folder. And there are a couple of reasons that might be. It could be because it was not unzipped. Even though it looks like it's on your desktop, if it's not unzipped, it won't read it. It could be that these files it didn't recognize for whatever reason. I don't know why they wouldn't, but anyway, if you're on Zoom and it's having and it like can't read this, one thing you could do is just like what I told Carolyn to do. You could toss the text files in here, and then use Carolyn's code if you want to.
Yeah.
Yeah.
Close before.
Yeah. So again, like the only difference between the main code and Carolyn's code is see how like I just had to type it. I had to tell it all the files I cared about. So if you just, again, I don't know if you guys on Zoom are having trouble or not because you're not telling me anything, but if you're having trouble reading this and you have Jupyter Lab, the main fix is to go in, the names by state, literally just select all of them, drag them in here so that you can see them here, and then use Carolyn's code. Okay, so from here, it looks like we have a lot of code left, but we actually don't have that much left. I just want to show you how I can do some basic data slicing and some basic plotting, and then we'll just do more sophisticated things Wednesday, Friday, and Monday. So Kara, so did it finish?
Yeah. No,
Okay. Yeah, so let's just look at what the data is real quick. So this line of code here, I just ask it like, hey, data, what's that? And it shows me. See it 8 in Alaska first. So state, sex, year, name, number. There's Mary in Alaska. So Mary was the most popular name in Alaska in 1910. There were 14 of them. Okay. So Alaska, of course, wasn't even a state in 1910. It was a territory with very few people in it. Very few, I guess this is all American citizen data also, right? So very few American citizens, so only 14 Marys. So in Alaska, you can just see how many female babies were born pretty quickly, right? Because there was only, with that caveat of less than 5 don't show up, right? There's only this many females recorded from 1910. Anyway, the reason I want to show you this is if you scroll down, see how it says there are more than 6 million rows? That's a lot of data. It's like way more data than, say, Excel can open. So this is one of the advantages of using JupyterLab over Excel, even when sometimes Excel can do the same thing. You try to open a CSV file in Excel like this, and Excel's going to crash on you every time. Way too much data. But JupyterLab is like, oh yeah, I know what that is, right? I told it, hey, what's the data? And it's like, oh, here it is. So it's just far more powerful than a tool like Excel, right? Even, this is technically a spreadsheet, but you know, it's too huge. So that's the data. So let's start playing with it a little bit. So I'm gonna move on to pane 3. So that, like, there's all sorts of stuff you could do, and we'll do a lot of them, but I don't know. What you do with this data depends on the kind of questions you want to answer. So let me just show you some basic tools. You can still slice if you want to. You just have to keep track of variable names. So way back up here, data is like the base data frame, contains all the data. Nothing's been crunched or combined or anything. So now if you want to look at just Missouri data, you can do that. So I slice, and then boom, here's Missouri data. So it starts back in 1910. Mary and Helen Dorothy, again, very popular, right? This is like the California list, right? Edna's there again, Gladys. Anyway, so you can slice by state if you want to. So here's all the Missouri data across all the years. Oh, one thing I should have said, by the way, what we're doing here can be done in Spider, but the reason we're switching to JupyterLab is the fact that previous cells running gets locked in. So once you run this cell right here, the cell 2, you don't have to crunch the data again. So on my machine, it took it like 1 minute to do this, you know, but that now that 1 minute is locked in. So now later, and all subsequent cells, it knows what data is. So that's an advantage of JupyterLab. You do your eating in of data up top, now it's eaten in, you don't have to spend time on it later. So again, this pane that ran instantaneously, you know, it's like, boom, here's Missouri data, because it ate in the data previously. Okay, so you could do that sort of thing. You could, what does this do? I commented this to remind myself what I was doing. That was a good idea. Yeah, so even the Missouri data set has close to 140,000 rows. Excel is going to have a hard time with that. Okay, so this next line of code, as it says, gets Missouri data with gender information ignored. So what does that mean? So let's just pick a name. Trent, that's a good name. Is Trent here today? We all like the name Trent, right? So there were 5.
I'm here.
Although I guess your name is Trenton technically, right?
Oh, yeah, but I go by Trent.
Trents in 2019. There may also have been some female Trents. I don't know. So maybe there's like 5 male Trents and 7 female Trents. Suppose you just care about Trents, you know? You can combine the female and males to just get an ungendered count. So that's what this is doing. So it's our group by command, but notice with group by, you can give it like a hierarchy. You can tell like, hey, first of all, group by year. So 1910 is its own bucket, 2005 is its own bucket, and so on. And then within each year, group by name. So we're going to go into like, you know, 2019, we're going to group then the Trentons together and then add up how many there were. So again, this dot sum, it's doing male plus female to get you just an ungendered count of Trents. And it does it instantaneously. And if you want to then see what that data frame looks like, here's what it looks like. So in 1910, in Missouri, there were 6 Aarons. Notice the gender column is gone. So you don't know how many of these were female, how many were male. Presumably they were all male, you know, I don't know. There were 22 Adeles, both male and female combined, and so on. So again, if you don't care about the sex of the baby, you just care about the name, right? A name count. Here's how you could do that. Group by year, name, and then add up how many there were. So again, this group by command is pretty powerful, and you can give it a hierarchy. Like, do go within a year, then within a year, go within a name. And then within that name of Aaron or whatever, add up how many there were. That's pretty nice. You can get just female information if you want to for Missouri. Again, this is all just like sample code to show you what you can do. I could provide this one just to show you this, remind you of this compound thing. You can slice for multiple things at once if you want to. So you can tell it, right, hey, go back to the data. This is the baseline data frame where all the data is, and then give me just female and just Missouri. And it'll do that. Takes a second. And if you ask it to show you that, there's just going to be F's in the gender column. See, F's all the way down, no M's anywhere, because you told it just slice for female. So all of our basic commands from last week, and I guess the week before, all that still holds for this data set, is all I'm saying. So again, what you would do with this code depends on what kind of questions you want to answer. So of course, I have some questions for you to answer later. But for now, we're just sort of getting used to the data set and the kind of commands you could do. Okay, so now let's move on to this next pane, pane 5. Okay, let me just describe to you real quick what this is doing. So we already have a big data frame called data that has all the data. It has all the data stratified by state, right? California is separate from Missouri, separate from Tennessee, and so on. Well, suppose you care about just the national data. So you want to count like the number of Ians, but you don't care which Ians came from California, which came from Missouri, you know? You just want a national database. If you want a national database, you got to add up all the names across all the states. And this pane does that for males, for females, and then ungendered. So I'm going to create 3 new data frames here, all of which are at the national level. So here's male data at the national level, female data at the national level, no gender at the national level. Creates 3 big data frames. And again, my machine is going kind of slowly, so it's going to take it a minute, I was thinking. But it does this pretty quickly relative to like, you know, what Excel could do or what you could do by hand or whatever. So now if I show you data M, let me show you that. Data M looks like this. In 1910, there were 111 male Aarons. It's coming from the National Male Database. In 1910, 31 Abes, 12 Abners. That is a classic name, right? Anyway, so notice the state information is gone, right? Because I told it, hey, just go within a year, go within a name, add up. And I asked it to do it within the global data frame, like where all the data was. So it went in. It went into each year. See how 1910 is separate? 1910 is separate from 2019. Ooh, Zeus. That's a good name, right? 133 Zeuses in 2019. Anyway, so it went in to, so first it went into the males data, went into each year, each name, added them up. So it just went across each state, added them all up. For females, did the same thing, by year, by name, add them up. So again, it's going like through California, through Missouri, through Kansas, adding up the same names. And then this again is no gender. So I notice I didn't slice by gender first. I just left female and male out there. Anyway, so now we have 4 data frames of interest now. We have the foundational one that contains everything. We have a national registry of male names, a national registry of female names, and then a national registry with no gender. So if I do data NG, this doesn't look much different. So back in 1910, Aaron was an exclusively male name, I guess. Aaron spelled like this. So there's still 111 of those. There were 28 Abbeys spelled like this. Presumably those are all females in 1910, and so on. So here's a national database by year of all names where gender is ignored. So, you know, what, Adele spelled like this. That 63 maybe contains some males and some females. We don't know because we decided to not keep track of gender for this one. Okay, any questions or comments on this? We've now done like 5 panes, I guess. Any issues either in the classroom or on Zoom? Okay, so let me just show you the rest of the commands here, and then we'll get started on playing around with the data yourself. So the next thing I'm going to show you deals with popular names and then plotting. So that's what we have to finish today. It'll just take a few minutes to go through these last panes. So suppose you care about 1984, a good year. That was the year I was born. It's also the year in which Wonder Woman 1984 took place. And that's the extent of my knowledge of 1984, really. But mainly it was my birth year. So suppose you care about, again, the 10 most popular names in that year. So notice what I can do. I can go into the ungendered national data frame. So again, data NG. This is the national database of names where I don't care about gender. So I'll go in there, create a new data frame called data year, whatever, and I'll slice by the year 1984. And then notice what I do. Inside data year, I'm going to group by name and just add up how many there were of each name. So I don't have to group by year anymore. Right, so the previous command said like that. I don't have to group by year because I'm already in 1984. It wouldn't hurt anything to put that there, but I've already sliced by 1984. Add up how many names there were, and then look at this. I'm going to sort it from top to bottom. So ascending is false. And then I'll just ask it to display the top 10 names. So here are the top 10 most popular names in 1984, and it only took me 4 lines of code to get it to display to me. So Michael was popular in 1984, as was David, which is my name. So my parents rode this David wave of popularity to name me here. Almost 40,000 Davids in 1984. Any questions on what these lines of code are doing here? Again, on Zoom, if you have an issue, you can shout it out. Notice this is ungendered, right? So I know that there were 40,000 or so Ashleys. I don't know if they were male or female. Presumably they were mostly female, right? But I don't know. So if you want to do the same thing, but like with males, all you got to do is like, see right here, I pulled from the national ungendered database. If I want it for males, I just got to change to look in the male database. So this will give me the top 10 most popular male names. So you notice Ashley's gone now. So David breaks the top 5 now, cracks the top 5 for male names. These are classic, biblical names here, right? Back in 1984.
How did you get to just be the male name?
So my original slice, I sliced from the database of ungendered names. So then I just said, oh, let me go back to the male name. So like but that's why I created these guys up here, wherever they were. Data M, data F, data NG. You can now use these whenever you want to later.
Right.
And it's a national database, depending on which gender you care about, or no gender. So anyway, here's what the code looked like. Okay, so anyway, when I named my children, I actually did this on here to get a sense of how popular certain names were in certain years. So there's one application for you guys. If you guys have a baby anytime soon, you guys doing that? Anyway, you can come in here and you can use this to figure out, you want to name, in my opinion, you want a name that's not super popular, but also not super unpopular, So you don't want, if every kid in your class is named Michael, then now the teacher's got to be like Michael 1, Michael 2, whatever. But you don't want it to be super unpopular, in my opinion, because then maybe your kid gets made fun of or something. Anyway, so now let's, oh yeah. So this next pane just does what I was doing with males. So you can, if you want the most popular female name in a given year, then just slice from the female national database instead of the ungendered one. So here are the top names, female in 2003. Emily, very popular back in the 2000s, as was Emma. What year were you born, Sabrina? 01, okay. No Sabrina. Emily's still very popular. Were you born in 01, Carolyn?
I was born in 00.
Let's see if Carolyn tops.
There's no-
Let's see if Carolyn cracks the top 30. I mean, why not, right? Let's see. Well, Emma wasn't so popular back then. By 2003, it was popular though. Yeah, sorry. I wonder how far you'd have to go. That's actually one of the homework questions. Okay, so anyway, so you can start looking for popular names. This last pane here involving popularity just says, well, suppose you care about the most popular name in, say, a given decade, over a given range of years, So now I don't slice by a single year, I slice by several years. So I'm going to start at 1990, see greater than or equal to 1990, and then go all the way up to 1999. So the year needs to be at least 1990, at most 1999. So that corresponds to the decade of the 90s. Here are the most popular.
So it adds it up over like any year that falls into that range.
Yeah, right. Because here I'm slicing by that, and then here, see, I'm just saying, hey, grab all the names you see, and then add them up. So this is the total number of Michaels born in the 1990s. Yeah, so it's close to 500,000 Michaels in the 90s. Notice in the top 5 of the 1990s, only one female name. The top 4 are all male names. What does that mean, do you think? Yeah, probably more variety in female names, right? I guess there also could have been more males born, but that's probably what it is, right? Let's see. Yeah, so in the top 10, there's only 2 traditionally female names, right? Anyway. Okay, so the last thing I want to show you is if you want to start getting pictures of things, JupyterLab is very good for that. In particular, the library matplotlib is good for that. So what this code does here is you pick a name. I picked Michael. And then you can plot the number of Michaels in the US in each year. So I'm pulling from the national database. You could do this for Missouri if you wanted to, or for California, whatever. It just depends on what data frame you want to pull from. So if I wanted to do Missouri, I'd have to pull from the Missouri database, like that. Change the NG to a Missouri, or whatever I called the Missouri one before. Anyway, so when I run this, look at that. So this is a plot of the number of Michaels in a given year, nationally, right? Because again, I'm pulling from the national database and ungendered. So presumably these are mostly male Michaels, but if there were female Michaels, they're contributing to this count right here. So what you're seeing is a history of the rise and fall of Michael, right? Michael, very popular in like 1958 or something, and it's been tailing off ever since. So anyway, here's the kind of thing that this code will let you do. There's actually, if you look at it, right, there's not a ton of code that's doing all of this, right? I mean, it looks like a lot when you scan your eyes over it, but really, I mean, to do a task like this, to eat in 6 million lines of a spreadsheet, you know, and go in and do all this counting for you, there's a lot of work that went into that, and the computer does it like instantaneously. Okay, let me pause here and ask, any issues with this code that's in here so far? Okay, we have 15 minutes left. So in that time, I do want you to go in. Most of the homework is taking the code that I gave you and just sort of like tweaking which data frame you're looking at. It is really fun though to just play with this. So I don't know if you care about Ian's. So oh, by the way, the first letter is capitalized, right? So if I ask it to search for Ian's like this, it plots nothing, see? It's like I didn't find any Ian's lowercase I, or if you do this, if you do Ian like that, it says, oh, I didn't find any of those. So anyway, first letter is capitalized and the rest is lowercase. Yeah, here's the rise and partial fall of Ian. So wow, your parents, right at the peak, because when they named you, right? Somewhere in here. So back in like the 1940s, there were like no Ians in the country, right? But then by 2000, there are like what, 6,500 babies a year or so being named. And now it's tailed off a little bit. So I don't know, I just like to sit here and play with this myself, like just. All right, let's see how you do, Carolyn. Oh man, so you have a 1940 name,
Yeah.
right?
An old soul.
So
Yeah.
where do you change that? You just change that where it's the name. Right?
Yeah, it's like, because right here I just say, well, look for this name that I told you. Yeah.
Oh my gosh.
So at Carolyn's peak, there were 20,000 babies being named that.
At my peak, there was 250 babies.
Yeah. Okay, so Karis. Yeah, always look at the scale, right? So here's like sort of a rise and fall of Karis's, I suppose, right? But it never got higher than 250.
Very 2000.
Yeah. Yeah, because it's like these plots are fun to look at because you can now say that, oh yeah, so it was a 2000s name, I guess. It certainly wasn't. See, notice it doesn't even register before 1980, really, you know. I don't know. Who's on Zoom? Let's see. Let's look at the potential rise and fall of Grant. Let's see how you do, Grant. Ah. So again, Rise and Partial Fog. Grant, I guess, was a very 1990s name. So your parents were a little late to the party, Grant, I guess. These little sub spikes are interesting, right? So like Grant is trying to go back up and recover its former glory here of over 3,000, but then immediately crashes the next year. Okay, so again, the rest of this week and then probably on Monday of next week, we're just going to play with this data and I'll show you what you can do with it. Again, it's hard to do data analysis in the abstract in a class because it all kind of depends on what data you're interested in and why you're interested in it. So I don't think this morning any of you were interested in baby name data, or at least none of you told me you were. But anyways, this is sort of an example of like you can go grab some data and then do some basic things with it. Okay, so again, we have maybe 10, 15 minutes or so. So if you look at the problem set, again, what you should be doing is like mainly just tweaking what I did, maybe doing some additional slicing if you need some additional slicing. But you see this question one, it says create a line graph, the kind of plot in the sample code. So I'm talking about this kind of thing, right? That I'm calling that a line graph. I guess I don't know what it's actually called. Total occurrences of your name. So we already did that for like 3 out of 4 of you in here. And then just see when it peaked, you know. So this kind of question shouldn't take you very long given the sample code. Now, if you want to do it for Missouri instead of nationally, again, this is a national plot here because I pulled from the national data frame. If you want to do it in Missouri, you could do the Missouri one because I created this one earlier. But if I asked you about California, you would just have created a California data frame earlier by doing that state slicing earlier. Anyway, so a lot of this is just taking what I gave you and seeing where you tweak it to make sure you understand what pieces of the code are doing what. Okay.
There were 9 Garrisons born in Missouri in 2000.
There you go.
And then there were 9.
Well, there may have been 4, 3, 2, or 1. You never know. Okay, so we only have 10 minutes left, so it's probably not worth doing breakout rooms. So I'm going to make a loop in the classroom and then see if you guys on Zoom have any issues. Let's see what you think about those sample problems.
The sample code understandable. So I have to read it. Oh, that's strange.
When you say in this question here, it says in what name is in what year did your name be covered in the country? You mean in Missouri?
Who's dead? I guess it's in Missouri. Sorry. Also, there's the.
I can't believe my name actually has more than 3 or 4.
Yeah. Hey, here's working, right? There you go. Does that code make sense how it's working?
We can just alter the code that you gave us
Most of this just.
as our code though. We just
Yeah, you don't want to make it from scratch.
Right, I know, but I'm saying we just alter what's already in Jupyter Lab.
Yeah, you can do it that way, yeah.
Yeah.
It is working for you. Oh yeah, so also, I mean, when you're doing this for your homework or whatever, you don't have, I mean, obviously you should take what I have and tweak it. You don't need to recreate it. Like, you already have this notebook open.
Yeah.
If you want to just not go to the bottom of this, start working with it, you can do that.
So for the old timey ones, we have to go each and every one of these names and do it separately.
Yeah.
Okay. So now we just do what we were doing, but just like now how like.
Right, and. And
I have a similar question, but can you check all the names here, or are they all separate?
so in general, if you ask, well, can I do this answer is yes. Like in terms of like what you realize.
Yeah.
So for example, they could have you one plot all in or something. But I mean, the easiest thing to do is just like type Helen, see what it does, and type whatever. Yeah, you can always give it like a list of names to iterate over or something, and it can go through just how you want to set it up.
Wow. was a very old time.
Yes, it's not gonna come back, right?
But we can't, like, we can't just put the whole list in there of names. We have to do each name one by one.
No, you could if you wanted to. It just depends on how you want to set it up. I mean,
I'm saying to give like a sufficient answer for this question, are the names actually old-time dentists, or each of these names determine whether or not the time period is they're popular? So for example, like I'd have to go name by name Helen and then say when, and then
Oh, Stella's coming back.
Alice and
That
then
is
say
exciting.
when, and then Stella would say when, and Nancy would say when.
right, yeah.
So you want me to go one by one?
I mean, it's a way to do it. So to you, I mean. if you
What's the
wanted-
other way that I could do it?
Well, I mean, you said that you created a list if you want to. So like,
Right. I just copied it, so.
we haven't covered this yet. but you
Yeah, I have a copy.
So you have to put them in quotes, you know, stuff like that.
Right, each one in quotes.
Yeah. But you could, I mean, yeah, you could, if you want to, and you would just need to like, coordinate and names, you know, that kind of thing.
Right.
Yeah. You could do that. Well, we're gonna cover this kind of iteration on the day of Friday, but yeah, I mean, there's nothing stopping you from doing that here.
Right,
It was
okay.
just,
What do you think, what makes what's the difference between these two though? Will it give me a separate scatter plot for each one here?
it will not, you know, just put them all in the same plot, so you have to know which one goes with which.
So how do we know which one goes with
So
which?
like, it'll just plot them all the same, I think. You know.
Oh, okay, so it'll plot the year that they were all popular.
Yeah, it should show up. Which is two of them.
Right, okay. Cool.
You plus both of them.
Oh, okay.
So you just have to know which one is which. So like,
Well, we have no.
you should put them on, plus you can always, we haven't done it yet, you can control which color it is that you move on if you want, but it always defaults to blue first and then where this one to go next. And then I forget what it defaults to, but it has some actually hierarchy of colors. So
Okay, yeah.
Oh, okay. You know, it's easy though. One of the issues that you can run into is like, so
Yeah.
if one of them is so much bigger than the others, then the scale is kind of wonky. So Stella actually, if you just ask to go Stella curve, it's gonna show you the up, down, up.
Yeah, I mean,
More
Stella
dramatic.
is coming back, but like coming back 5,000 names isn't that much compared to like how little do that, like 35,000.
Right, right. So here, like,
Stella's coming.
so see your graph to the right, so like if it choose the scale appropriate to the name,
Right.
then you can, it looks more dramatic, I guess. On
Yeah.
Here, yeah, I mean, Helen is just dominant, right, because Helen's so popular back in
Yeah, Helen's balling over there. But so I think the better way to do it is just go one by one.
Yeah, but I mean, you're right, that surely there is a way to do iteration over lists, and there is, there's so.
And then for the answers here, you want me to be like, okay, Helen, like for example,
Yeah, just was it old timey enough? So basically, like, did you see, like a big spike in the past?
yeah, okay, so I'll just say very old time.
Sure, yeah.
Does that work?
Yeah.
Okay, anybody on Zoom have any issues with the code? Anybody on Zoom have any questions over the sample, the problem set that they want to ask? Let me just choose a name here, random, that I see. Grant, are you okay?
Yeah, I'm good.
Mallory, you okay? Everybody on Zoom is all right?
Yeah, I'm doing good, thank you.
Okay.
It's sort of fun, right?
No, yeah, for sure. So Stella's theoretically making a comeback.
Yeah, it's all relative, right? So it's never gonna reach Helen proportions from the 1910s maybe, but. Right. Why are you so excited about Stella?
I'm just happy for her.
I want your attitude. Yeah, we should celebrate.
Right? I know Valerie would be happy. I just miss her.
You think? That makes sense, like ours with the code, which one?
Yeah.
Which name is that?
It's like,
Oh, Sabrina, oh,
yeah.
interesting, wow, it's like, it's actually not that popular relative, but those spikes are like
Yeah.
all over the place. One of those, that's just in Missouri, right?
Should be.
But this one was the national one? Up here.
Yeah.
That's interesting. So I wonder what would cause, like, what caused that dip? I wonder.
Oh.
All right, so we're running a little short on time. There's only actually one homework set left that consists of this problem set plus a few others, like one on Wednesday, Friday. The homework's not going to be due until a week from Friday. So let's just have it due in the last week of class. So you have plenty of time to get this done. If anything bothers you, as always, what you should do is come to office hours, shoot me an email. Don't beat your head against the wall, right? If number 5 bothers you, number 4 bothers you, don't spend 2 hours trying to solve it. Shoot me an email or come to office hours. All right, so I'll see the Wednesday people in person on Wednesday, and everybody else, I'll see you on Zoom on Wednesday.